Or
Like if it happens
where
that
where we get like the same value of, yeah.
yes.
Oh, we usually don't get something like that because we are interested in finding the area between those two curves. You get me? So if there's no area between the two curves, then therefore the thing becomes zero because the two curves are going to cancel one another. So
Okay, okay.
there's no area between a function like this. If I've got a function, maybe let's say it's here, and I have another function which goes exactly there, it tells us that the area is equal to zero because there is no movement between the two curves. Did I answer you, my man?
So that means that statement of f at x is greater or equals to is not that much favorable to something like that because it says equal, greater, or equals to.
Mm-hmm.
That statement that we be Santantra statement whereby you said f at x is greater or equals to g at x.
Yeah, yeah, I remember that thing. You are saying
So
what?
I'm asking that we can just only say f at x is greater than g at x, or we can only say g at x is greater than f at x.
No, we cannot just assume. That's why I said it is important for us to know how to draw or to prove if that thing is true. But if we get a case where we are saying that f at x is equal to g at x, then we cannot find any area between the two things because they are equal. That's why we do not consider the part where f at x is equal to g at x. You understand that part?
Okay, I get you.
Yeah. That's why at the beginning here I said it has to have this condition or this condition, right? It's important. Né?
Okay.
But if they are equal, then the area becomes, you don't need to worry about which one lies above the other one. It doesn't matter because they're at the same point. You understand?
Okay.
Yeah.
Thank you, the punish.
So are you sure that you are getting it? Okay. So any other question, guys, before I move on? Okay, let me check in chat. Okay. All right. So if you are fine with that, we can continue. Yeah? All right. So guys, please, I told you even last year, guys, I do make mistakes as well. So there I was so relaxed thinking that it was 2, but it was 7x. That's very bad. Okay, so now we are going to look for the area. Oh, we did not define. Eh? We are going to define that our y is greater or equals to h at x. Ne? You know what that thing means. So we're going to move from 0 to 10 over a 7. Okay, guys, we are running out of time now. We're running out of time. So when you have something like that, we're going to have this function y minus h at x dx. Are we fine with that? Ne? Then with the continuation, we know that our y value, 0 to 10 over 7, our y value is given by 7 minus 4 all over 2 minus x. This one is going to be very interesting, guys. I like this one. Now, my question to you guys is, how can we solve this one such that it becomes a function which is very easy to be integrated? One can say, let us have a lowest common denominator. One can say, let us leave it like that. One can say, there's so many things. There are many ways to kill a cat. But I have got only one question for you. Ne? Have you ever tried to integrate 1 over a minus x dx? If you have tried to do that, please help us and assist us on what we are going to use to solve for this.
Substitution rule.
There is this thing called integration by parts. You did it, right? Guys, you didn't do integration by parts. That's the substitution rule, yes. But that thing only works for what? For this type of questions. Guys, you are saying you didn't do that. When a lecturer is here, I can ask him. I can ask the lecturer. Guys, you can't do it like that. Guys. Okay, it's fine. Ne? So I'll do this one. But I've already given you hints. It's one of the things that you are doing this here. Oh, I'm not sure if you did it. Let me check. Let me yeah. What I'm going to use here is something called partial. Ne? Is there a question there? I believe somebody was asking a question.
It's not a question, but as I remember last year, I think we used the denominator.
Oh, you use the substitution. Well, yeah, we can use that one as well. That's the one I like the most. But since we, oh my God, since we didn't do partial fractions, I wanted us to introduce partial fractions, but I see I'm very far with this. I'm very ahead. Guys. I'm very sorry about that. 10/7, 1 dx minus. Now we said we're going to use substitution. Substitution, and we're going to say that u is equals to 2 minus x, du is equals to negative x, negative dx, and then negative du is equals to dx. Then what we are going to have there is 4 integral from 0 to 10/7, and have 1 over u negative du. Okay, guys, from here you can complete it. I know, I trust you. Okay, so do we have any question? Guys, me, I'm very excited. I was nearly making you do partial fractions. I'm very excited to do this. All right. So if you don't have any question, the solution that we should have there, it should be something like x minus, it's plus 4 ln, but our u is given by 2 minus x, so I can write 2 minus x. Yes, my guy. Is that a question? Okay. All right, as I was saying, so we're gonna have something like this, but we're gonna consider it only from 0 to 10/7. Actually, somebody gave us the solution here in the chat. Let's see who's that. Avail yourself. Who's Majadi Body? Yeah, that person gave us the solution. But now, this person got a negative. How did you get the negative now? Majadi Body. How did you get I don't know how to pronounce that, guys. Yeah, very okay, but so far, do you get the main logic behind this thing of area between two curves? Guys, are you still laughing at me even more? Guys, serious, man. You cannot do that. You cannot do that. How do you pronounce that thing? Maja. Oh my God.
Majadi body.
Majadi board, yeah. That's what I said. Majadi board. After, how do you call yourself that? All right. So guys, should we continue? Are we fine with this thing, guys?
Can you please do any example that got sin t sin x equals what something that got trig functions?
What? Yeah. All right, so let's continue, guys. I see that you don't have questions. I was expecting to get some questions, but I can't get them. Okay, let's do another one. Let's do another one. As much as we got time, we are going to drill this. But this is going to be the last one. I need to introduce Aklen, then we can do 2 examples and then the session. Okay, let me do